In this video, we're going to take a look at the Cardiohelp system from Getinge, formerly known as McKay. First, let's take a tour around this pump. This is the hardware unit that drives their disposable oxygenator and pump system. And this has the front where there's connections that we'll talk about. Here's the user interface here. And as you flip it around the back, then we also have the place where the motor mount, where you're going to mount your pump and your oxygenator system, a bunch of plugs. We're going to start our tour of the back here. To access the back of the pump, we will open this guard by pressing two buttons and lift the lever up. And now we have easy access to all these ports and the motor, the mounting unit for the motor and the pump. This is an example of our disposable set. I've taken all the tubing off of it, and we can see that the motor is here. There's a loop on the bottom and there's a loop on the side that coincide with a pin on the bottom and the pin on the side, and this lever connection here, which presses in to secure and release the device. So if we're going to place this oxygenator in here, we approach from the side, tip just a little bit clockwise. When it looks like it's seated flat, tip it back, that latches in. To remove that, push that button in, rotate it back, and it comes right off. For the moment, I'm going to take this off, so we can talk about all the ports that are on the side here. This pump has multiple modes, some for use in cath lab, some for use in the operating room, and some for use in the ICU for ECMO. Given there are these many modes, then there are many ports, connections back here for a number of external devices. For the purpose of this in-service, we're demonstrating the McKay as an ECMO system for VA or VV ECMO. And so we only need a couple of these ports, and we're not going to discuss all of them. I've uncapped the ones that you're likely to use for your VA and VV ECMO. If we start at the bottom, this is a arterial flow probe and bubble detector with red markings on it. Corresponds with a red lined port down here, and it shows you a V dot for flow and little pictures of bubbles for the flow and bubble detector, red for the arterial line. Plugs in, red dot, line those up, just push it straight in. And with these connections, now that is secure. To take it off, you grab the collar and pull the collar back towards you, and it comes right out. So let's put the arterial bubble and flow probe, connect that in there. The other end of this line then would be connected to the arterial line. The arrow shows you the direction of flow. There's a lever here that opens the door. You put the 3/8 inch tubing through there, close that on it. We'll put that on later when we have a circuit on the pump. Another connection you will almost definitely use is the SVO2 monitor. This is actually two pieces. These two pieces here come apart. The SVO2 monitor has this shape. There's a shape of module right there. The SVO2 monitor goes on the blue side of the circuit, on the venous line, so there's a blue stripe around that. And again, we're going to look for a red dot, line it up with a red dot there, push it straight in. To remove it, grab the collar to pull it out. If you don't grab the collar, it's tight. The other side, the other end of this has a mounting bracket here for calibration. There's a little tooth down here, and there's a little loop right here that we're going to intergauge the loop and the tooth and close that up by rocking it forward. That's secure now. To take it off, you push this button and rock it down and out. This is the mounting station. This is the mounting station. So when you turn the system on and power comes to this unit, it will calibrate based on the known reflectance of this black plastic. So you really do want to connect this. When you're assembling your circuit dry, you leave this connected here. You don't put it on your asynchronous circuit. You put this here. When you power this up, it will calibrate and work better for you when you are finally ready to use it. So place that there for now. Place this here. Your institution may also use a venous bubble detector. That would be placed here. There's a blue line around that indicating it goes on the venous side of the circuit, and there's a little pictures of little bubbles. It would look a lot like this one, slightly different shape. They've changed the color a little bit, and they put blue stripes on it, and the size of the port is markedly different, so you can't mix up your arterial and your venous. Bubble picture down here, bubble picture up there. I don't have one of those to demonstrate for you today, so I'm just going to put the cap back on that. The last piece we need for our setup today is going to be the data cable that connects to the oxygenator. The oxygenator has integral electronics for pressure sensors, and that data is going to come out of the unit here and go in that port there. So there's two ends to this port. The one with the red dot connects up to the red dot there. Black cable, black stripe. Go straight on. The other end of this is going to interface with the oxygenator. So let's put our oxygenator back in the unit. There's a port right here for the other end of this cable. This cable has a right angle on it, and the right angle is always oriented this way. The wire comes out and points back out across the oxygenator. This goes in. Just give it a little wiggle, see that it seems like it's fitting well, and then press it in tight. It's worth noting with this cable that as it fits on, it needs to go down tight. And watch the space down here. Push it down until it's tight. It often seems like it is interfaced well, like that, but the connections have not been made, and you'll have errors and missing pieces of data on the front of the screen. So push that on tight. With our arterial bubble flow probe connected and our venous set crit monitor connected and the data port for the oxygenator, we're done back here. So I'm going to press my 1 button, drop the door. Having placed our disposable and connected our electronics, why don't we spin this pump around now and take a look, turn it on and take a look at the console. The front of the console here has two major areas. Here's the user interface up here, and there's more connections and plugs down here in the bottom. Taking a look at the bottom, there's a plug for AC power, and there's some grounding element and some DC current element. There's some other elements here that you might use for transport, and there's some data plugs down here and some networking plugs as well. There's a big enticing button over here behind a fancy red spring-loaded door, and that in there is a press button. This you might think is something that you're going to use a lot, and it calls out get your attention, but you're probably never going to push that button. That button is going to be an emergency only button. The power button is actually located up here. So why don't I get a power cord, plug this in so it doesn't beep at us while we're doing this in service, and we're going to turn this on, take a look at the menu system. Okay, this button right here is for power. And press that once and the screen will light up. To press the power button. Already it has some alarms. And then we're going to go through all of the real estate that they have on the screen here and the buttons they have on the side as well. There are a few high priority buttons here that they would like you to not be able to accidentally press and cause their activity to happen inadvertently, so they require that you press a second button. And this button over here that says S could be your second button. I think they call it the safety button, and prevents you from doing certain things like doing the global override. But the first thing I'm going to show you today is the global override, because it's complaining that we have error and it's going to keep beeping. We could silence it with our typical medical silence alarm here, and now it should stop beeping for a little while, but it'll eventually kick back on again. We're going to be talking for a while, so I don't want to have to keep pressing the normal silence alarm that you find on every medical device. And we're going to do a global override. We're going to press the S, and then we're going to press this button here, and the two of those together, holding this down and then pressing those, it gives a global override. Now, it won't make any sound. It's not really paying attention to any of its alarms. If you want to turn that off, all you have to do is press this once. You can silence that, and you can override all of this. Press this, hold it, touch that. Two buttons to turn it on. It's difficult to turn on. It's easy to turn off. Okay, let's work our way through the screen here. The menu across the top, we're going to look at this column first. Starting here in the top left-hand corner, you can see a red icon, and it's got a picture of a heart and a lung in it. This is the mode that it's in. They call these THAPs, the T-H-A-P. The THAP is a therapy application. The therapy application right now is in the heart and lung mode, which is typically considered to be your VA ECMO mode. And I'll show you when we get to the Tetris bar over here how to change and go through different THAPs. There's really only two of the 4 or 5 THAPs that are in this that we're going to use. And this one is currently set to VA ECMO. This menu here, from there to there, is going to show you the highest priority alarm. At the moment, the highest priority alarm is the bubble, that an arterial bubble has been detected. This can be have no color in it. It can be yellow or it can be red, and the words there are, again, highest priority alarm, and not necessarily the most recent alarm, but the one the machine thinks you should be dealing with first. The next item over here tells you whether or not the screen is locked or unlocked. That picture says it's unlocked. That means that if I touch the screen, things can happen. If we lock that screen, we can press this button. We can manually lock it right now. And now the screen is locked. You see the icon has changed. And if I want to press anything on this button, I have to do a 2-touch system. So I touch something, it says, hey, I'm locked. Now you press the 1, you press the 2, and now it's an active screen again. Working our way across, we got the time of day, and we've got the time of day. There's a little space right here, and more information will pop up when we start data collection. You're going to see an icon that shows you that we are recording data. So that's working our way across the top. Let's go down this column here. We have the home button. This home button looks a lot like this home button, just a little bigger. I guess it's just perspective. This one's closer to you, that one's further away, so it looks smaller. They're exactly the same. They take you to the same place. The next button down here is sometimes called the Tetris button, and that takes you into, it pulls out a menu and shows you a bunch of things. There's 6 different items in there. There's 5 different items and a leave button, and let's go through them. This one is about your pump flow. It's an icon of a centrifugal pump, and you can put this system here into RPM mode or LPM mode. In RPM mode, this knob controls RPMs, and you turn it to an RPM. When you release it, that's what you have set. You've set an RPM. And the flow, because these pumps are preload and afterload dependent, the flow will go up and the flow will come down, but the RPMs will not change. If you're in RPM mode, the RPMs stay to what you set. If you switch this to LPM mode, then what you've done functionally then is as you turn this knob, you are changing the RPMs, but you're setting a flow. I don't have any fluid in the system for you to show you this. You would turn this and you would set it, say I take my hands off of this and it says 1 liter a minute. Now, you're in LPM mode. That means that you set 1 liter a minute. The pump has the permission to increase and decrease the RPMs as necessary to maintain 1 liter per minute. It is, in my experience, it's not super popular or common for programs to run in the LPM mode. If you're doing veno-venous ECMO, it would probably have very little impact unless somebody were kinking the lines or you had a significant preload or preload problems. It's hard to get an afterload problem without a kinked line in VV ECMO. If you were doing veno-arterial ECMO, however, if you were in LPM mode, then as the patient's blood pressure changes throughout the day, then you would maintain a steady flow. But in my experience, most centers run in RPM mode, so we're going to leave that in RPM mode. And we're going to get out of this menu by pressing the green check mark here. That's going to enter the data. The next icon in the Tetris, behind the Tetris menu, is the THAP, the TH-APP. It's a therapy application. And behind that, you'll see the 5 different modes of function that this pump is built for. And it has the red heart and lungs. It's got the blue lungs. It's got this teal-colored lungs, and it says CO2 with an arrow down. It has a picture of a heart with a teal background, and it's got a picture of a heart with a purple background, and it says MECC. And if you were to put these into applications based on where you're going to use this device, this is designed as a ventricular assist device. This is not available in the USA, but in the UK, they have disposable sets for this pump. They have only a pump and they have no oxygenator, and that would be your VAD mode. The MEC is for minimally invasive cardiac surgery, and this would be used in the operating room. The CO2 is for ECOR, extracorporeal carbon dioxide removal. It's not that much different than the veno-venous over here. And the veno-venous and the veno-arterial ECMO is kind of how these are envisioned. And by selecting a THAP, what you're telling the system is which of the ports on the back and on the front of the machine it should be collecting data from or sending data to. So if you were to switch back and forth during a case from a VA ECMO mode to a MEC mode, the system would just turn on a bunch of ports in the back that you don't have anything plugged into. It wouldn't have much consequence except for the data stream that you're collecting. The pump would continue to run. So you can refer to your manual to find the subtle differences between all these modes, but for our purposes for ECMO, you're always going to either be in red or blue, and it almost doesn't make a difference which one you choose. So let's leave it in red for now, and we're going to hit the green arrow. Let me show you what happens with that X. This is a process that's preserved throughout the system. If I select the blue, let's say I want to go to veno-venous, and I hit the X to get out of this screen, it's still in red. It's still in the VA ECMO mode. If I wanted to switch to blue, I need to go to the Tetris, I need to go to therapy application button, I need to select the veno-venous, and I hit get out of this screen by entering the data. The green button enters your selection. So now it'll enter the selection. It's going to ask, do you want to change the application? We're going to say, yes, we do. And it's going to say, then check the settings and limits, because if it thinks if you just change your application, then maybe all the parameters you had previously set, not appropriate anymore. But you see now the icon is blue. Let's just change it back to red. Let's enter that selection with the green checkbox. Let's confirm that we intended to do that, and let's promise it that we will check our limits. Go back to our Tetris button. The third button over here is the settings, the systems, selections, things like which version of the system we're using. You can change the brightness of the screen, the loudness of the alarms. We can go to night mode, etc. So basic system settings. back in the menu here, therapy application, systems. Oop, there they are right there. We have brightness, we have language. There are many different languages you can select from. Time of day, settings for the time of day and month and year. And this is in the service mode. It requires a password right off the bat. This is when your Gedinga rep comes and does the in-services on, not in-service, but does the PMs on your equipment. He's going to go into that system. So let's go back to our therapy, back to our Tetris button. Let's work our way down. We see a folder with some arrows on it, and this is going to be about recording data. The data recording intervals can be as large as every 10 minutes or as small as every 45 seconds, 30 seconds, 15 seconds, 3 seconds. Many choices for data collection. And so you pick your interval, and then you have to turn it on. You have to tell it, put the data in the folder. Previously recorded data will be deleted. That's okay. You hit that. Now data recording is on. And you notice up here in that little real estate space I was telling you about earlier, there's now an arrow pointing at a folder to tell you that you are recording data. And we can stop recording data. And it goes away from that menu up there. This icon down here is going to be used when you want to get the data out of the folder and put it on the symbol for a USB drive. And that's in those ports down here on the front of the machine. There are connections for a USB. You can plug your USB in and get the data out. The exact steps for that are in your manual and beyond the scope of this presentation today. We're going to leave this turned off. We're going to enter that. Go back to our Tetris. Look at the next menu in line, and this is going to be the list of running errors. We can see that we've had a bubble detector, arterial bubble detected on this date at that time, and all these other times as well. So this is the alarm history. It's not infinite. It doesn't go all the way back in time. There's a certain number that it records, and it tells you this is now the order in which they happened, whereas the display up here is telling you the current most important error. This might have happened a while ago, and 2 things have happened since then, but since it's a yellow-coded error, it's still on top, and the white-coded errors are not being displayed because you can only display one thing at a time. Back into Tetris, we've worked our way around. There's the pump, LPM versus RPM. Pick your 2 of 5 therapy applications, change the date and time and the brightness and the loudness, turn your data on and off, and look at the alarm history. The X closes the Tetris window. We've already come down and shown you how to do a global override with 2 buttons here, and this is your typical silence alarm there. A little blank space, nothing goes in there, and this is your battery function. It tells you that we are not using battery. We're using power because you see the plugged in symbol here. And if you click on that, it tells you that we have a bank of batteries and they're 97% charged. I'm going to reach down here and unplug that system for a moment, and we can watch what happens to that. You can see when you unplug that the icon starts to flash. We're in global override, so it's not giving any audible alarms, but it is flashing that we are not plugged into the wall anymore, and I'll go ahead and plug that back in. And it immediately corrects itself. Let's take a look at how this screen changes when we unplug it. Now we can see the icon is flashing, that we are not plugged into the wall, and it's giving us an estimate of 9 hours and 56 minutes of battery power, given that we're only pumping at 75 RPMs. There would be audible alarms, except that we've done the 2-finger. There we go. And when you're in global override, it's not going to tell you about these things. Plug it back in, and it will immediately correct itself. Let's close that window. All right, let's keep working our way around the screen here. So let's go to the bottom column down here, and let's move from left to right. We said this home button is the same as that home button. The home button, in this case, for this STAP, are these six pieces of data. The data that's displayed on the home screen is determined by the THAP that you choose, and if you were to change the THAP, you'd get different pieces of data on the screen. The home screen for the red and the blue, or the VA and the VV ECMO THAPs, are the same. If you want to see more than these 6 pieces of data, then you can select this button here, and you go into that, and it makes the boxes smaller and gives you more data. So we have flow, P venous, the pressure of the venous line, P INT, P internal, which otherwise is known as the premembrane pressure. You have the delta P, which is going to be the difference between the internal and the arterial, because the P arterial in Cardiohelp speak is equivalent to the post-oxygenator pressure in every other ECMO system. And then we have the temperature arterial, and we have the SVO2 RPMs. That's everything. If we go to the button that's shaped like a test tube, then it takes you to a category of data that are things related to laboratory values, like your temperature of the venous line, the temperature of the arterial line, the hemoglobin, the SVO2, and the hematocrit. The next button in the line here is the ambulance button, and that makes the boxes bigger and larger so that you can see them from a distance away as you're transporting the patient. It eliminates things that might not be that important to you while you're walking and driving, and makes them bigger so they're easier to see. The link button down here is the intervention screen, and it gives you a listing of all the things that can have an intervention set to interrupt the flow or slow the RPMs of your pump. It doesn't, if they're on this list, it doesn't mean that they have been set. It means they can be set. And we can discuss in a moment how you set the interventions and how you know that they're turned on or turned off. The last button here, there are 4 timers on there. We have 1, 2, 3 that count up, and this one counts down. Okay, let's go back to the home screen and set some parameters around these variables. Let's say, for instance, we wanted to set some limits on the venous line pressure. So we're going to press this button here to go into this menu, and it's going to take us to the venous line pressure alarm settings, and we can tell it when we want an alert and when we want an intervention set. That picture of the interlocking links is when you have the data you put in there, that's going to trigger an intervention. You don't get to choose what the intervention is. They're set into the system, but the interventions are going to they're going to slow the RPMs and perhaps all the way even to 0. They may, at different interventions, may allow the RPMs to move up and down to maintain the flow to 0. So you'll have to learn what the pre-programmed intervention is for each of these and determine whether or not you want to turn it on and at what limit you want it to come on. So right now, what we're seeing is that this is the venous line pressure. It should run in negative. So this system was last set up to have a alarm at 150, and then an alarm at 100, and have an intervention at 150. So what that's going to do is it's going to give us an audible alarm and tell us, hey, your line pressure is now minus 100, but it's not going to change anything until it reaches minus 150. At minus 150, it will start to reduce the RPMs as necessary to make sure that this doesn't get any lower than 150. If we want to turn that on, then we would press this button here, and it's grayed out. So that can sometimes be frustrating, that you think, I want to turn this on, but I don't know why I can't turn it on. And there's 2 things to look for. Does the system even know you're plugged into anything? As in, is the connection on the back there that we looked at earlier, is it nice and tight, and are you getting data from the venous line pressure? Because you can't set an intervention to a transducer that it can't find. That's one thing. So let's go check that. And here we are, venous line pressure. There's a number in there, so it must be getting data. So it's going to be the second thing. You can't change these interventions when you're in global override. So let's, for a moment, take it out of global override. Just need to touch this once. All right, start getting some alarms. And you see that this is not grayed out anymore. So when you're setting up the system, and before you are connected to your patient, and if you wanted to go through and set all your alarms, you can't do that while you're in global override. So here we go. We've set an intervention. I think we have. Yep. Now we've set the intervention. You see that the icon fills in with color, and we're going to enter that selection. And now we see a red set of links in this box. So from this screen or any screen that P Venus appears on, that screen as well. I don't know where else it appears. Probably doesn't appear anywhere till there. You can see that the intervention is set. If you go to the intervention screen, you can see everything that you can set an intervention for. Currently, there are interventions set for these 2 items, and if you want to, you could turn them off. Or you could come in here and say off, but if you hit the X, it's not going to happen because you actually backed out of that without making it show the change. So that's how you set interventions. You can set the interventions and the limits for pressure arterial. Let's select the 400, turn that down to 350, just for an example, or 375. Now it's down to 375, and if we go up here and hit the 500, the 375 is ready to go. It'll enter if I hit the green checkbox. Let's turn that 500 down to 450, 500 down to 450, or 490 is fine. Hit the green checkbox, and I will have changed the limits. They're now 375 and 490. If I want this pump to slow down its RPMs, when the pressure reaches 490, I need to turn on the intervention and hit the arrow. Hit the checkbox to enter that. There's an intervention set. You can set an intervention for the P internal. You can set an intervention for flow, although we can't play with the flow probe right now because the flow probe is not connected to a tubing with fluid in it. Another thing you're going to want to do on this interface is to zero these transducers. The proper time to zero these transducers would be similar to now when we are just setting the system up and before we add any fluid to the system. So let's go into our venous pressure and let's access this button right here. It's a 0 with 2 arrows pointing at each other, and that's how we zero this. So if we select that button, it's going to say, is the system free of fluids? And you have to say yes. They want you to zero the transducers when they're all under atmospheric pressure, so they all have the same reference point. So we're going to say it is free of fluid. My circuit doesn't even have tubing on it over there, and I hit that. And now when we come back and look at this screen, we should see that the venous line pressure equals 0. The P arterial is equal 4. Let's zero that one. Let's touch that. Touch that. Is free from fluids. Yes, it is. Now it's going to set to 0. We enter that. Calibration. Good. P internal. Into it. Zero it. Accept it. And if we go back to the home screen, we're going to see the delta P is 0. The home screen, you should note, venous line pressure, arterial pressure, delta P. This is a calculated number. It's not the third pressure. It's the calculated number. The difference between the P arterial and the P internal. No P internal on this screen. P internal is on that screen. So when you're setting this up and you want to zero your transducers, you have to leave the home screen to get the venous, the internal, and the arterial. Or in other worlds, the venous, the pre-membrane pressure, and the post-membrane pressure. Another thing you may do on this screen is enter data, say for instance for your SVO2 monitor. If you're running a case and you don't like the data you're getting from your SVO2 monitor, you would disengage it from its clinical position, which is here on the venous line. That venous lines, the venous saturation sensor will be mounted here on the venous line. There will be a piece of tubing that goes off to the patient's venous cannulas. And you would disengage that here by pressing the button and rocking it off, taking the tooth out of the loop, and then placing it up here in this position. The tooth in the loop. Close that up. And you could come around and then tell it to initialize. And it's telling you to attach the venous probe to the holder, which we just did. And wait for it to say that it's done. Once it has initialized successfully, disengage it from the calibration bracket and place it back on in its clinical position and drop the door. Another thing you can do from your SVO2 screen here is enter data. You can save the data you're reading from your SVO2, put it into a folder, and then when it comes back, you can recall that data, and you press that button, and it will tell you the data that's in the file, and you would change it to the data you're getting back from the laboratory with your arrow buttons. You'd say, if there's a 70 over here and it's supposed to be 72, you would tap that and move that around to 72, and then enter that data. I don't have any data, so I have to X out of this. But we've covered the inside of the SVO2 monitor now. This is what it's reading for saturation and hematocrit. It tells you the device that is connected, the status of the probe, and you can recalibrate it during a case. You can save data. You can recall the data. When you recall the data, you can change the data on that screen. You can set alarms. We're on the if we go to the intervention screen, you see there are no temperatures here. The pump won't take control of your system and turn RPMs up or down based on a temperature. But you can set limits around that. So you can go to your temperature arterial, and you can tell it when you would like to get a beep of some kind, if it's above this or if it's below that. Very smart system. You can tell it to monitor a number of items, and it'll let you know as soon as you leave your parameters. With that, I think we've covered everything that's on the screen. Finally, to finish off this presentation on the front console and its menu system, let's go back and revisit this shiny red light down here. So this button down here, the emergency button, I sometimes jokingly call it the N times button, because they only want you to press this if this system is actually broken. So given that it's a computer, there's some computer smarts to the system, and it has you may have given it the ability to turn your flow up and turn your flow down, or even turn your flow off, then if you were to lose this interface and this screen were to break, say in transport, something heavy falls on the screen, cracks it, the screen doesn't work anymore, then the computer might still be working, and you can't interface with it, and that would be a dangerous situation. Therefore, they give you this button, and then if you press and hold this button for the right period of time, it will turn off the screen, and it will disengage the CPU. And then what you have is just a dumb pump. You've got a knob that controls RPMs, and it's entirely up to you. You'll have no data because the screen is dead. You'll have no alarms. You'll have no limits. You'll have no safety. But you've got a knob that you can turn up and down and control your flow. You might wonder that if you lost the screen, how would you have any idea what you're flowing? How would you know when to stop turning the knob? And what they do is they give you a backup monitor up here. This monitor strip up here has LEDs in it, and it will tell you the RPMs in thousands, units of thousands. So it will tell you if we can turn this off and turn that on, we're going to see light appear up there, and we're at about 2,000 RPMs, 1910. So if the screen is broken, you'll press the big red button on the front. It becomes just a big dumb pump. In fact, let's do that. I'm going to lift the gate, and push the button, and listen for the alarms. Now if I release it, you're in emergency mode. Touchscreen is deactivated. Control using the rotary knob only. All interventions are deactivated. Switch off. The only way to get out of this is to power the pump off now. So this is not something you want to do unless you actually break this screen. All right, we're moving towards assembling this circuit now. So let's look inside the tubing pack. It only ships one pack. There's one standardized pack for anybody and everybody. You can't put custom things in here. So if you've seen one pack in one place, you've seen the same pack everywhere else. So we would open this up, and it's all packaged in a similar way. This one's obviously been used pretty heavily for ECMO training, but it's generally organized in a pattern like this. What you have is your tubing pack right on top, and the oxygenator velcroed in over here on the side. The AV loop and its clamshell pack has a special hook on the side here that thing slides on, and we're going to repeat that kind of a theme when we place this loop on the pump as well. It's designed to hold this in place. For a moment, well, let's look at the pack a little bit. The pack has the red striped lines and the blue striped lines. Inside the clamshell pack, there's a package of plastic sterile tubing clamps that could be used at the field. And we have the lines that go out and connect to your oxygenator here. And the other end, after the loop, there's some lines that come out, and they don't connect to anything. They have on them some special caps which have some quick release connections. And these quick release connections are part of the overall system here that make it easier for you to connect and disconnect. They've got a little button. You press the button, and then you pull the two apart. There's a male end and a female end, and you can push them together, and they immediately lock. Press the button, pull them apart. The way they put the circuit together, they mix the males and the females such that you could take this one off, take that one off, and then these two pieces that you want to keep sterile, you can connect back to each other. You wouldn't need these anymore, but often clinicians will connect them together and put them somewhere where they could access them later, because they are capped on this end, and now you capped them sterilely on that end. You could come back and revisit that if you needed to. But when you open this up, each of these are capped with their respective quick disconnect. And all this is inside the pack. Now you would normally grab this and take it off and put it on the pump, and then grab the next thing underneath. So let's remove this from the pack and set it out of the picture for now. And obviously this is like all the other tubing packs that you work with that's sterile on the inside. And if you wanted it to stay sterile, then you wouldn't set it on the floor and let your scrubs come over here and touch it, and you wouldn't reach in there with your dirty hands and start touching things. You could put this on a sterile field, open the lid, put on some sterile gloves and some sleeves, and get in there and make some modifications, although there's virtually no modifications you would want to make to this anyway. But by the way, I recognize that I'm not using a really great sterile technique in this video, where I'm just showing you the contents and the layout of the tubing pack. Here the oxygenator and the pump system are coming out. Notice that there is a yellow cap in a sterile wrapper taped to the top of the pump, just like that. That's for your use later. You put it right here where it says close after priming. This yellow stripe goes with that yellow cap, and it goes on that air vent right there. But it comes out of the package there. They want it off during priming, so they don't put it on when they package this for you. All right, this is all going to go out of the picture. We'll come back later. The next thing you're going to find down here in the tubing pack is going to be the priming bag. It's got a Looks like about a 3-liter bag with some chimneys on top and some lines that hang down out of that, which also have these quick connect. And as you can probably imagine, we're going to connect this to the ends over there. Let's just move this over to the back side, and then we'll have miscellaneous gift packs, I like to call them, in here. This one has your pigtails and some extra connectors. This has the high flow lure port with a spike on it that goes on the post oxygenator side of the oxygenator for rapid access to oxygenated pressurized blood. This comes standard in the pack. Also in the pack are a pair of sterile scissors that you could use for cutting. And down here I have other things. There's probably some tie bands in everybody's pack as well. And most of these things are in their own little packages inside. Put all that back. Let's go ahead and get this priming bag then hung up on an IV pole. And we'll bring our pump into the scene here, and we'll put the tubing onto the console, connect it up to the priming bag, and get some fluid in this. All right, let's start on our dry setup. Here's our tubing pack. Here's our Cardiohelp console. We've got an IV pole, 2 liters of fluid ready to go. I'm gonna open this up. Find all of our sterile stuff. We can also plug this in. Get this turned around. So I'm going to start. My business end is over here. Open the door with 2 buttons. Flip that up. And take the tubing loop and the pump oxygenator cassette, the HLS set, out of the tubing pack. And put this in, locked in place. I can drop the door and could place this on top. The space back here that was interfaced with this rim right here inside the tubing pack is designed to fit right over top of that handle, tightly like that. So now the top of your pump becomes a tray that you could push up to the sterile field, open the clamshell pack, people can access it, and you can grab the garbage and go away. Now we're going to need our electronics hooked up, so let's access our electronics. Here is the arterial bubble and flow probe. Plug that in down here, line up the red dots. They intend for you to put that on the arterial side. There's a set of white tapes here and here. And the flow probe can go there, although it would work anywhere. Just make sure that your arrows are pointing towards the patient. We have the sat crit monitor. Find our red dot. Put it into the jack that has the icon that looks like the sat crit monitor, and connect it to the handle, to the guard up here on its mounting bracket. Next we have the data cable, necessary for the pressures and temperatures. They're going to come out of the data from the oxygenator itself. Black cable, black ring, red dot, line up the red dots, press it straight in. On the other end of this, there's a red dot here, there's a red dot there. The right angle comes up, goes back across the oxygenator, press that on. And make sure it's tight. We can grab our priming pack, put that on an IV pole. And they want you to have at least 30 inches of height. I don't quite have 30 inches of height, but it will prime faster and better if you raise this up. In here we also have our gift packs with some pigtails on it. And let's add the pigtails then to our oxygenator. Here's the post-oxygenator outlet. Put one of these pigtails on there. Here's another post-oxygenator outlet. Put another pigtail on there. And then here's the pre-oxygenator. Put the last pigtail on there. Take my pigtails while I have them in my hand, close them, closed, close. Then we can connect the venous lines and the arterial lines of your AV loop to the red and the blue lines of your priming bag. Red, red, quick connect. Quick connect, and keep these sterile. Put these together. Now I have some things to do electronically to turn this on and zero some stuff, but that takes a little bit of time, just as running these bags in takes a little time. So why don't we spike 2 bags and get some fluid accumulating over here, and then while that's running, we'll go over and turn on the electronics. So before you add any fluid to this, clamp these quick connects. Clamp these thumb clamps that are on the arterial and venous lines. There's another set of those after the quick disconnects. I'm going to clamp those as well. There's a spike hanging off the arterial side above a one-way duct mouth valve, and we can spike this bag and let this fluid run in. Now this bag would run in all by itself if I could hang it higher than that, but I've got an IV pole where everything's going to hang at the same height. I think I'm going to try and lower this bag down. Let gravity do my work for me. All right, while that fluid is running in, why don't we turn this pump on? And before we add any fluid on this side of these clamps, and while this system is still just full of air, that's the best and recommended time to zero your transducers. So let's go through our menu items, and we're going to go to we're going to leave the home screen. We're going to go to the screen that has all 3 pressures on it. And we're going to find one at a time. Go to the pressure venous, tell it to 0. And it says, is the first system free of liquids? Yes, it is. We've zeroed that one. And then P arterial. Zero that one. Silence the alarm. Can't silence it yet. There we go. P internal. Zero that one. Close that screen. They should all read 0. Looks like P arterial still says 1, but it's pretty darn close. We would probably just leave that alone. There, all 3 of them are 0 now. With that taken care of, I think I can put this in global override so it'll be more quiet. And we can move on with the priming. Now I let this bag hang low here so it would fill by gravity while I was working on the transducer zeroing. So we'll pick that back up now. And I'm going to have to raise the bar up a little bit and get more height. Make sure you close this clamp or your water will run back into that bag. Work on some height. Now we have our prescribed 30 inches of height. Go ahead and open the clamps. And the gravity is going to run down the venous line. It can't come down the arterial because of this fish mouth valve. And going down the venous line, zip through the loop here, go down into the oxygenator, fill the oxygenator, back up the arterial side, and there'll just be some air left in the arterial that we will push through once that pump is primed. All right, we're going to open the 2 arterial clamps, and we should see nothing because the fish mouth valve won't let the flow go back in that direction. So now I'll open the 2 venous clamps. And away it goes. This tubing has been kinked many times. And that's providing a little turbulence. It's holding it back a bubble. Now I'm squeezing this bag. But you shouldn't have to do that. In a brand new clean system with 30 inches of height and 2 liters of fluid, and there's never been primed, a circuit that's never been primed, this happens seamlessly without any effort on your part. As a perfusionist, we often feel like we need to reach out there and pat this box and get things to move along, but the truth is, on a sterile, clean Cardiohelp system, you pop these clamps, it primes itself. So now that we have fluid down here to the pump, the next thing to do is to add some RPMs over here. So let's go ahead and turn up the RPMs. Manufacturer's recommendation is something like 3,000 RPMs for 4 minutes, and then 4,000 RPMs for 1 minute. See the fluid starting to move, the bubble's starting to move. And you can hear a sound. I can put my mic down there. You hear air breaking up and moving through the system. We have 5 liters a minute, 3,000 RPMs. You can start a timer so you know how long you've been doing this. And again, in a very clean, brand new clinical unit, it doesn't take very long. But right now, it's starting to get a little quieter. It's very quiet now. And we've only been doing this for a little over a minute. I started the timer late. But if you were to let this go for the prescribed 3 minutes, 4 minutes, and then turn up the RPMs a little higher for another minute or two. You should be very satisfied with how well it de-airs itself. If you're bored about now, you can go ahead and look around. I'm seeing nothing. Look at this side of the oxygenator, and do you see some bubbles at the top? And they're either going to come through eventually, or I'm going to bleed them out of these pigtails. So why don't we do that? Why don't we grab a syringe and go ahead and burp each of these pigtails. So there's going to be 3 pigtails that we could address here. The post-oxygenator pigtail. We do this with a sterile syringe and sterile connections. Just let a little fluid out, put a sterile cap on that. The higher post-oxygenator pigtail here at the top. Sterile syringe, sterile connection, turn the stopcock, bleed the air out. Sterile cap. And then on the inlet side, pre-oxygenator side, there's another pigtail here at the top, right next to P internal. Vented cap. Sterile cap. Now, I've given this demonstration dozens and dozens of times, and I've often been asked, do we have to wait this long? And certainly at 7 minutes, no, we wouldn't. The manufacturer would suggest you only have to wait about 4 minutes. It takes about 4 minutes to prime this thing, and it does it very effortlessly all by itself. But just to prove the point, I have stopped the priming as soon as we didn't hear air anymore, and then disconnected the cassette, the oxygenator and pump system, and taken it out and shaken it around and looked for air, and there was no visible air that I could see with my eyes. So the 4-minute recommendation from the manufacturer seems to be very conservative, and if you really were in a hurry, then once you stop hearing air, you can feel pretty good. Always certainly wait the recommended 4 minutes, as long as you have that time to wait. So now we've been doing this plenty of time. This is 8 minutes. I think it's perfectly quiet. So let's get around and do the last couple things we have to do. So at this point, what we have left is to confirm that there's no air. We'll do another visual check on that. We need to disconnect from this priming bag, and we need to zero the flow probe. So let's go ahead and turn our RPMs down. The RPMs are 0 now. I'm going to grab a tubing clamp. I'm going to place it on the arterial line, right where there's a little marker with a piece of tape that looked like a pair of tubing clamps. Place a clamp on there. Truth is, you could push it anywhere on the circuit as long as there's no flow, but there's a clamp on the line near the flow probe, and with that, you can go ahead and zero the flow probe. I'll do that in just a second, but as long as I'm standing here, let's clamp these lines. I'm moving the thumb clamps closer to the connection because this fluid here is probably going to spill out. Then we can disconnect this. Connect the bag to itself just to keep the sterility and minimize the mess, and put these two together. You see there is a bubble in there, right here, but that's not going to be a problem as long as we keep it between these clamps. So the clamps are closed, the bubble is trapped. This bubble is never going to make it to the surgical field if we are careful with these clamps. Let's zero that flow probe now. If we're done with this timer, we can turn it off. To turn it off, you tap the numbers. Now it's not moving anymore. To reset it, press and hold those numbers. And now you can go to another menu. So to zero the flow probe, looks like we don't really need to because it's already reading 0. But the method for zeroing the flow probe is after you have fluid in your system, then you place a clamp on the arterial line where there's a piece of tape that shows you that you should place clamps there. It's right next to the flow probe. Although the truth is you could put it anywhere. And come over here. While the RPMs are 0 and the flow is 0 and confirmed by a clamp, you can touch the flow. Go into this menu, press the 0, and it asks you, is the tube clamped upstream and downstream of the flow sensor? We've got it upstream. That's good enough. Confirm that is true. And then it just re-zeroed, and you can enter the data. So with this system fully primed, I don't need the IV pole with the solution on anymore. And we'll wheel that away. And we can start thinking about how are we going to interface this with our sterile field. So let's pretend there's a sterile field over here. This obviously is not sterile. None of this is sterile. The only stuff that's sterile is inside the pack. So what you can do is break the tape on this pack. Wheel this whole thing up close enough to the field that your surgeon can reach it. And open this with your best sterile technique. Not hanging your dirty body over top of the sterile field. Fold this away. And then somebody from that side, who is sterile, gown and glove, can reach in from there. If you couldn't get your system close to the sterile field, you can, there's a place to hold this down here, and you could take this and hold it out to them, and secure the lines in a way similar to how you hand lines it to the field in the operating room. So you can now interface with the people who are on the sterile field, and they can come with their gown and gloves, and they can access the things that are inside that pack. You can point out that there's a package of sterilely wrapped temporary tubing clamps for their use if they would like, but if they have metal ones on the field, they can use those as well. And when they are ready to use a pair of sterile tubing clamps, then you're going to direct them to clamp the lines. I'm going to reach into this pack. Doesn't feel natural to do it. Right there on the red and the blue lines where there's a piece of tape that shows you a picture of a clamp. So then someone from your surgical team who's wearing sterile gown and gloves and has sterile clamps can reach into this pack and they can find the tubing and clamp it. And then your next instruction to them is disconnect these quick connects here. And connect these two, the two that have the clamps on them, back to each other. And then you hold on to this pack for them, and their tubing, their loop, will go away. This goes up to the field. This pack then is not connected to anything, and you can take it away. Let's take a look at the McKay line of oxygenators. Well, they're not McKay anymore. Let's take a look at the Gedinga line of oxygenators. Starting on my left here is the McKay Quadrox ID pediatric. Moving on to the McKay Quadrox ID adult. And this set over here is the HLS Module Advanced 7.0, which looks to me a lot like a Quadrox in a red wrapper with a special gift on the back. One at a time, let's go through their anatomy. There's a lot of similarities here. We have a pre-membrane side, post-membrane side. Blood comes in, blood goes out. Blue blood goes in, red blood comes out. Water connections on the bottom, gas out on the bottom, gas in on the top. On the pre-membrane side of this pediatric oxygenator, there's 3 connections. On the pre-membrane side, there's 3 connections. I said that twice because it's different than the adult sizes. The one at the top in all 3 units is a gas vent. The close-up here will show you that there's a membrane back there that lets air out but does not let fluid across. So if there's air inside this device, you take off the yellow cap. Air is channeled to the top based on the geometry of the oxygenator, and the air wicks across. Once the air is gone, the fluid touches the filter and nothing moves then. On this pediatric unit, then there is a lure connection here that does communicate with the blood phase, and that could be used for your pre-membrane pressure monitoring, because there's no connection for pre-membrane monitoring on the 1/4 inch connection that's down here. And that's different than the adults. In the adults, that pressure port is on the inlet where you put your tubing. On the outlet side, we have the 1/4 inch connection that goes to your tubing arterial line back to your patient. We have a pressure monitoring lure connection that does communicate with the blood phase, and we have another pressure port up here that does communicate with the blood phase. So if you look at the adult and the pediatric units, they have a lot of similarities. They both rack right here, and they're held by their holder here, shaped like a diamond. And on their pre-membrane side, they got 1 blood in. They've got a pressure port and a pressure port. They've got a gas wicking port here and here at the top of the diamond where the air is going to accumulate. Turning them in the same direction, we've got the gas inlet here, and the gas outlet is on the bottom there. Water connections, water connections. Blue blood goes in, red blood comes out. The adult oxygenator has another couple ports over here that the pediatric does not. It has a 1/4 inch port with a lure cap. Well, it's a 1/4 inch slip fit, but this actually screws on like a lure and can be screwed tight. This would be used if you wanted to use this oxygenator in the operating room. You could use that for cardioplegia or some other supply, maybe a recirculation line if you wanted. But in the ECMO arena, there's generally no application for that, and it just remains tightly fit. This is a temperature port. It looks like an open 1/4 inch port, but it's not. There's a steel base at the bottom there, and a temperature probe goes in here and locks on. And then this port also, this adult oxygenator on the post-oxygenator side has a large lure, which has a spring-loaded valve inside here. This cap then, if you take it off, when this is fluid-filled, nothing comes out. Nothing comes out until you push something in there and depress that spring. And then high-pressure arterialized blood can come out of the system. And there's a special connector that ships with the oxygenator that fits right on there. At the top of the diamond, then, there is also another normal-sized lure connection that does communicate with the blood phase, and we generally use that for air removal, just as this is for air removal, only this one is passive because it has the filter membrane behind it, and this one is active. You would have to have a pigtail on that and draw your air out with a syringe. So those are the standard classical pediatric and adult Quadrox models. The next evolution of the Quadrox model then was when the Quadrox was married to its pump. Now this is the Rotoflow pump, the classic McKay Rotoflow centrifugal pump. And when they made the HLS set, they took a pump and they combined it structurally with an oxygenator. Now, more functionally, it looks something like this, where the inlet of the pump is still a separate connection. That's right here. And the outlet of the pump goes into the oxygenator, but they changed the geometry quite a bit. This pump that's over here, this is the pump on the back of the back of a Quadrox. Now these two oxygenators are in the same orientation. We're getting something that works like this, an inlet pumping into the oxygenator. Then the oxygenator is relatively normal, the same here and same there, very similar anyway. But they changed the geometry of this pump, so the inlet actually points like this, and it's been bent around the corner. So this is the inlet of the pump, comes over here, turns the corner, and then goes back in this direction to the inlet of that pump. Pump spins it around, and that outlet then has been turned to face this way, like my fingers. So it was connected like this. So the blood comes down this venous line, turns a right angle, goes in here, turns a right angle, goes into the pump, spins around, and then comes out through 4 channels. 1, 2, 3, 4, and goes into the front of the pre-membrane side of this oxygenator. Pretty cool stuff. That's the old technology. I'll set that aside. And let's go do what everybody has always wanted to do. Let's open this up and see what's in the internal space of the HLS set. Inside this looks like a relatively normal oxygenator, but it's got 4 channels. And those 4 channels match up with 4 outlets of this centrifugal pump. When it all comes back together again, the inlet is here. The blood goes to here, into the pump then, round and around, comes out these 1, 2, 3, 4 channels that are right here. 1, 2, 3, 4 channels into the face of the oxygenator where the blood then finally meets the fibers on the inside. Now because this covers so much of this face of the oxygenator, then they had to move something, and they moved the pre-membrane port. That pre-membrane sample port is not on one of the channels, but it's right up here near the top, and it actually interfaces right there. So that port right there is the equivalent of this port right here, equivalent in function, but there are some very minor technical differences with having it at the top versus the bottom. Also, what we see in here is some of the electronics. So this is a pressure sensor that is attached directly to the plastic, and that has had an electronic cable that connected over here. And we have another pressure sensor on the inside, on the inlet of the pump, so we can get a venous line pressure. This would be your venous line connected to this. And the venous line pressure pre-pump is monitored right there on the inlet of the centrifugal pump. Then it goes around, comes out the other side, and now there's a pressure on the oxygenator. Here's the first pre-membrane pressure. And then when we get to the other side, there's another piece of electronic technology embedded right in the plastic here on the outlet. And this is the post-membrane temperature and pressure. Pre-membrane temperature and pressure. Pre-pump or venous line pressure there. And all 3 of those devices communicate to this electronic ribbon that comes up here and provides us access to the data. When this all snaps back together, we get our data from those 1, 2, 3 different sensors right here. By connecting our data cable, and that data cable has a red dot here and a red dot there, and if it's on like this, if it's on like this, turns back across the oxygenator. And then that would fit into the Cardiohelp console. Pre-membrane pressure sensor. Post-membrane pressure sensor. Electric cable runs around the side, goes into the space here, the Never Never Land that nobody gets to see unless you happen to have one of these that you can tear apart. So when you disconnect the pump from the back of the oxygenator, you fold it out, you can see a pressure sensor there, and a pressure sensor inside the inlet of the centrifugal pump. The pre-membrane pressure, the pre-membrane sample port has been moved to the top of the oxygenator here. Oxygenator sits like this. There's your sample port. Here's the air venting port. Sample port, air venting port. And the data from the post-membrane, pre-membrane, and venous line pressure, pressure, temperature, pressure, all comes out this cable to the surface here.